In May 2006, 4 fatalities occurred at a partially reclaimed waste rock dump at the closed mine near. The fatalities occurred at the toe of the dump in a seepage monitoring station that was connected via a pipe and dump tow drain from the covered waste rock pile. On May 15, 2006, a contractor went to take a routine water sample from a monitoring station sump and collapsed at the bottom of the 5-foot ladder. As was commonly the case, the contractor was working alone. Therefore, no search was conducted for the contractor until a family member inquired about his whereabouts. A mine employee and another contractor went in search of the missing person across the mine site. The mine employee found the contractor's truck and subsequently discovered the contractor in the sump. He called emergency services and the contractor company, then entered the sump to attempt to help the fallen contractor, but also collapsed. Another person arrived on the scene and also called emergency services. Emergency services arrived. One EMT entered the sump to rescue the 2 victims and was overcome and collapsed. The second EMT was notified of his partner's collapse and went in to assist her, but was also overcome. In all, 4 people were killed when they entered what was later learned to be an oxygen-deficient atmosphere in the monitoring station. First, some background on where the incident occurred. Number 1 shaft waste dump curves along the slope below the shaft in a southwest to northeast direction. It is about 1,000 meters long and about 250 meters wide at its widest point. It has a height of about 55 meters from the toe to upper flat portion. The waste dump was created over a period of about 60 years, starting in the 1940s. During operations, the top surface was used as a pad for mine offices, shops, and pumps. The dump contains about 3 million tons of what is mainly rock taken out of the mine, and the total dump volume is about 1 million cubic meters. About 30% of that volume is void space between the broken rocks and soil material. In the early 1990s, it was discovered that acidic seepage was moving away from the area through shallow gravel lenses underneath the dump. A ditch was installed along the dump toe to intercept the seepage so it could be conveyed to a water treatment plant. The seepage collection system was so successful that it was determined to be needed as part of the dump closure plan. Before the dump was reprofiled, the ditch was filled with coarse rock, so it would continue to collect and drain water even after the dump slope was reprofiled to extend out over the area. In 2005, the entire dump, including the reprofiled toe and seepage drain, was covered with about a meter of soil. At the time, revegetation was expected to start in 2006. The seepage that collected in the ditch and later the toe drain was routed to a low point of the dump toe. From there it flowed through a 400 millimeter or 16-inch diameter pipe. The pipe was used for several years to collect seepage samples and measure seepage flow. The monitoring station was routinely visited without incident over many years, including only 1 week prior to the fatalities. Oxygen-deficient air causes a wide range of effects that worsen as oxygen levels drop. At 16% oxygen, symptoms include impaired attention and thinking, increased breathing rate and volume, increased heart rate, and some coordination loss. At 12%, symptoms include very poor judgment, impaired respiration, possible heart damage, very poor coordination, nausea, and vomiting. At 10%, symptoms include possible unconsciousness, impaired respiration, inability to perform vigorous movement or loss of all movement, and vomiting. At 6%, possible unconsciousness, spasmodic breathing, cardiac standstill, convulsions, and death in minutes. At 4%, unconsciousness results after 1 to 2 breaths, and death comes in minutes. The technical panel was asked to consider whether this type of incident could happen elsewhere. The general conclusion was, yes, it could. That part of the technical panel's investigation focused on 3 factors: the reactions that create a hazardous pore gas, the movement of the gas within and out of the dump, confinement of the gas where it exits the dump,